I want to do now, not going into details of this, but want to do what is now exciting about this. You see, for the first time, you see now you have a circuit with the 3 switches, right? Before we had a circuit where it was in this circuit that we are going to do, these 3 switches has to have, these three switches are inherently directly connected with the resonant inductance, because this resonant inductance is not PWM inductor. It had set and reset a volt-second balance only during the short circuit, during this period. And therefore, it is not switching between DC voltage VG and DC voltage on the output, which are large. It is actually resonating in off period with the ripple on this capacitor. That's why it is much smaller, okay? So that's one thing. And the other thing is now when we have this circuit, we just showed that this circuit can be both positive and negative, right? My next step is, oh, this was a negative and this was negative, both are negative. But remember, this one, we just got positive here and got this way. So we got output is positive, output negative. Now the question is, what do you think happens when I have this positive part and this negative? I can generate from positive supplies negative output, positive output, which is what normal all converters do, right? Except the bad Chuk converter, which is polarity inverting, right? And then you can do polarity inverting like in a Chuk converter. But if from the same positive source, I can have polarity inverting and polarity non-inverting. And what is the change in this case?
Over 2 diodes.
The change is direction of the diode, right?
Right.
Positive and negative. But now, let's make another key point. I can have polarity of this reversed. Because polarity, negative input, what is going to happen on the output? It will be plus minus, right?
Yep.
So I have positive polarity and generate positive polarity output. I have negative polarity on output. I have positive polarity output, but the diodes are changed, right? So what it really says is that now I can have a converter which has here positive part of sine wave, 0 and 0. You see? And this here could be a negative part of the sine wave.
Yep.
0, 0. So it doesn't tell you now that I have a topology which is much simpler, doesn't have inductor on the output. It can have accept the positive polarity on the input and negative polarity on the input, and essentially makes it like, hey, I can use this to power factor correction. This circuit, can be used to make power factor correction. So, and then we'll talk about that more in the future. But it has only 1 transistor, 2 diode, and then to add at the top of that, if I have this, what about having the isolated version?
Oh.
Now, okay.
Split just like you've done. Split the capacitor and put your transformer in the middle.
Exactly. That's what I'm trying to say. So what I'm going to do here, I can make a. Is this going to work? Still, yeah, this works. So we can actually put here. Red, whatever. Red. So we put here magnetizing inductance, split this into 2 capacitances and magnetizing inductance here. And voila. All I did, no change in the switching structure, nothing. Just what I did originally, Chuk converter, this capacitor is split into 2 in series, and I put AC transformer in it. Do I need to do all this thing which is done with a full bridge, push-pull bridge, right? You have buck converter just to get isolation. You need a full bridge on the primary side and full bridge diode on the second. You have 8 switches. You don't change anything. You have the same transistor and diode, right? Isn't that better? You don't have 8 switches just for isolation. But it's even better than that, because what it does is now it's ready to have power factor. It has boost front end, and it has power factor correction on a boost front end, isolation transformer here, and eventually the output. So you have only 3 switches, which normally you would need what? You would need many more switches just to get DC input to DC output, rectification, boost, and then isolation and power, like 16 switches to do what you do here with the 3 switches. And the transformer is really working always. It is always, how to say, charge balance, and it doesn't have a DC bias, and it's true to AC transformer versus the full bridge, which is not, which I have one of these webinar lecture that I encourage you to go and see why the full bridge is not really working, because you can have charge imbalance on a secondary rectification, and therefore it is not, it can saturate from either primary side on volt second imbalance or a secondary side of charge imbalance, and you spend 8 switches to do that. You know why? You know, so that's what I'm saying. This is a bad way of doing it. This is a good way of doing it. Okay, let me tell you now other part which I wanted to cover. When to satisfy Mr. Rao, who didn't like my converter with the 2 inductances, so I'll give him another converter with just single inductance. Okay.